Hi guys, Craig here and welcome back to the channel. Today I'm going to be focusing on the Renogy Rego. This is a 50 amp DC to DC charger with a solar controller built into it. So it's a maximum of 50 amps output. Now it comes pre-fitted with these Anderson plugs, as you can see, and also a temperature plug there on the end. Where is it? Little green one. There it is. So I've just labelled them up: alternator, battery and solar. They give you the other end of the plugs so you can wire them into your system. It comes with a manual. There it is there. The important thing to note about this is going to be cable diameter, guys. So they're suggesting 6 to 9 meters using 6 AWG cable, which is commonly known as 13.5 mil. And it is sold here in Australia sometimes as 16 mil squared cable. So just watch that. You may not be quite getting 16 mil squared if you're buying 6 AWG cable. The basic information on this thing. So there we go there. It's a 12 or 24 volt charger. So that's great for guys out there that got 24 volt systems. Most people, I'm assuming, are going to be having 12 volt setups. So that's the way I'm going to test it. Battery input voltage range 9 volt to 32 volt, solar input 15 to 50 volt, maximum solar input voltage is 50 volt. Now that's obviously critical, and solar output 720 watts, which will be your 50 amps. Now my understanding is that this will run up to 50 amps in a combination of either DC to DC charging and or solar, and I believe you can turn the solar off if you want to focus on your DC to DC charging. Now that might be handy for after you pull up, change your parameters, and then ramp up the solar to your 50 amps if you're capable of putting 50 amps on your vehicle, that is. Bluetooth integration with this, so it works on the Renogy Home app. CAN bus ports there for other Renogy products that run CAN bus. It's IP67 rated, I believe. You've got your outputs here on the side. So what I've done is I've discharged the Renogy Pro Lite down to around 51%. So we know we're not going to go into absorption or anything like that. So we're not going to hit our 14.2 volts. I'm going to simulate a DC to DC charge with a battery that I've got down there that's fully charged, and I'll keep it topped up so there's no chance of voltage loss. I'll demonstrate running the DC to DC on short cable lengths and long cable lengths and see what impacts that has with voltage drop and output charge. So stay with me on this one. I really liked this product when I first got it, and that's why I've left it to last. I'll do as much testing as I can for it. You'll also see I've just lifted it up slightly. I've thrown some nuts underneath there just to give it a bit more ventilation, because as we know, DC to DC chargers tend to run reasonably hot. So I just wanted to give this thing every benefit to obtain that 50 amps output. So stay with me. So I was just about to plug in the charger into my battery there to simulate the alternator, and I've just noticed that this cable here is 10 AWG cable, which is only about 6 mil squared cable. Now in my mind, I know it's a very short run. It's probably only 30 centimeters or 1 foot in the old money, but in my mind that's going to heat up. That cable's going to heat up. So we'll test that throughout and see how hot that cable gets. So I'll just plug it in now, and I'll get the Bluetooth up and running, and we'll see what sort of output we can get into the Renogy Pro Lite. Okay, so now I've got it plugged in. I've got the battery plugged in. Everything's up and running. And as you can see here, auxiliary battery charge amps 49.94, and I saw just over 50 amps. So it's putting out the 50 amps. But the interesting thing is the starter battery, which is what I've got plugged in to provide the charge, which is this battery here, which has pulled down the voltage. We're down to 13.38. It's pulling actually 57 amps on that side to achieve the 50 amps on this side. So there you go. That was a very, very quick test. I've just plugged it straight in and it just works. So I haven't done anything with it. Okay, we can look at the settings up here. We can set your maximum combination of charging amps, your charging type, your system voltage, your forward start voltage 12.8, etc. So low voltage, boost duration. I'm not sure what the boost function does. I'll have to have a look into that. And as you can see here on the Renogy shunt, it's putting in 52 amps or 718 watts, which is near enough to the right number. I'll come back out of here. Yep, holding that 50 amps. I'm going to let that run for a little while now. We'll see how hot this charger gets. We'll see how hot this cable gets, because I'm worried about this cable. That's already warming up now. Again, yes, it's a very short run. And overall, I'm only running at about 1 meter. So I'm going to introduce a longer cable shortly. I believe that's about 10 meters long, which would be representative, close enough, to somebody running from their start battery in their ute or their tow vehicle down to the rear of their caravan, where the Renogy Pro Lite would sit, for example, with the DC to DC charger. And we'll see what effect that has on output. So I've just introduced the solar into the system, and it dropped out for about 30 seconds, but interestingly, so we've got solar charge amps of 2.96 amps, and you can see now it's generated a little bit of solar, but the auxiliary charger amps has now dropped down to 31 amps or 433 watt, and we're still holding good voltage on the starter battery. It even says here 13 volts on that, but it has derated slightly. Starter battery amps 27 with auxiliary battery 30. Now, it only happened when I introduced the solar, so what I'm going to do is disconnect the solar and see whether it goes back up again. Okay, so I disconnected the solar. The charging stopped for about 20 or 30 seconds, and then when it started back up again, bingo, straight up to 59 amps on this battery as discharging, and charging with 50 amps on the Renogy Pro Lite. So I'll have a look into that. The interesting thing also is have a look at this temperature coming up. We're now at 68 degrees on the DC to DC. And if I just test that here, yeah, so we're over 50 degrees here on this unit. Which, look, they do run hot. Other brands run hot. Then it's a known thing. This cabling is not, sorry about that, is not too bad. But down here, when you feel this cable, like that's getting, you know, hot to touch. The other side of it, that's the orange flex I've got there. That's 16 mil squared attached to that battery. I've also got a battery charger attached to that battery to hold the voltage up. Yeah, like it's warm to the touch at this point. Yeah, that's getting very hot. So we'll keep it running. This is a good test for this thing. I'm actually happily surprised that it can output 50 amps. I really like that, and the fact that it's 12 volt or 24 volt will play into the hands of some people that have got 24 volt systems. I kind of like the built-in Bluetooth, so you can run it straight on the Renogy Home app as well. Oh, that's getting hot. So basically now you can't keep your hand on that. So that's getting too hot to touch. 53 degrees, 54, so it's still climbing. And you look, the internal temperature says 72 degrees C. Now, I'm not sure what's going on when I plug the solar in, why it's cutting out. Again, I haven't used one of these. I've set up the basic parameters for this, and it's on a combined maximum of 50 amps. And when you go into that, so you can turn it down in 10 amp increments, but that's not going to help us with the solar. Low solar current shutdown. Okay, I had it set to 1 amp, so I'll confirm that again. Yeah, as you can see there, 1 amp for solar shutdown. And nothing else stands out as to why the solar would bring the overall amps down. I'll plug the solar back in and I'll show you what it's doing. Okay, so we've been plugged back in now with the solar. As you can see there, we've got 39.1 volts, but it hasn't connected, so we're not charging with any solar, and I'm not sure why. I'm thinking it's because we're still at the 50 amps on the DC to DC, which is the maximum amps that the system can put in. But I thought it would do a balance between the two, but it looks like it focuses on the DC to DC as the primary source of charge. What I might do is disconnect the DC to DC and then see what happens with the solar. Temperature still climbing, 80 degrees C. That's starting to worry me. So that's the internal FET, so I would imagine. Yeah, 59 degrees here externally. And the cabling, yeah, there we go. So the cabling on the DC to DC now is starting to heat up as well, over 50 degrees. Holy shit, that's hot. All right, I'll unplug the DC to DC and we'll give the solar a chance. Yeah, unfortunately, it's a crappy day outside, and we're only getting 51 watts off the solar input, or about 1.65 amps. So it's not going to be a fair test on the solar, unfortunately. So I think I'll focus on the DC to DC charging. I can't pick the weather, guys. I've got a spare day today to run this test. So, you know, I'm going to continue on. Unfortunately, it is what it is with the solar. So I've plugged the DC to DC back in, and as you can see, 389 watts charge. And over here, we're showing 304 watts. We're still showing we're getting solar, but then it's that same problem again. When the solar is plugged into with the DC to DC, it seems to limit the charge for some reason. I don't understand why. If anybody knows the reason behind that, let me know, because that's a strange one. All right, so what I'll do now is I'll disconnect the solar. There's not enough solar out there to really make any difference anyway. I'll introduce a longer lead and see what that does. Okay, so I've introduced a 10-meter lead. Now this is a lead also, it's a Renogy lead. It comes pre-fitted with Anderson one end and ring terminals the other end. It's a high temp silicon cable. If we can just get the specs on it. It's 6 AEWG, 105 degree, well, sorry about that, 6 AWG, 105 degrees C. So remember, 6 AWG is not 16 mil squared, it's about 13.5. I think it's actually 13.3. So we'll see what that does. While that's ramping up, you can also, you've got a display here as well. So there's your Bluetooth. You can select your battery type here. And you can see your status. So you can see there we've got no solar input. We can see the alternators on, and we can see the batteries on, and that's your battery type. So, okay, there you go, guys. Straight away, look at that. Starter battery volts are now 11.9 volts. Okay, but the voltage here, we're still showing 13.18, or let's call it 13.2. But look at that. We're only charging at 441 watts. Now that's a result of me introducing this 10-meter lead. And I'd suggest that you're going to need bigger than 13.3 millimeters squared. You're probably going to need 20 to 25 millimeters squared, so you don't get the voltage drop and you can maintain the output. You can see we've dropped to 39 amps and we're getting in 31 amps. So clear as day, that's a direct result of a longer lead. Okay, and I can prove that again. I'll disconnect the long lead, plug in the short lead, and I guarantee you that's going to go straight up to 50 amps again. Short lead reintroduced. Back on the unit. 700 watts, 49.25 amps. So if you're going to run long distances, you're going to need a very thick diameter cable. I'd suggest 16 mil is not going to do it. I think you're going to need, between that 20 and 25 mil, possibly even larger, but who's going to run a 35 mil squared cable? That's just getting out of control. So what I might do is I'll get a shorter lead, say 3 or 4 meters at 16 mil squared. I'll put that in and we'll test the output. Okay, short lead introduced. It's the orange high temp flex cable. All right, that's about a 4 meter run now. So we've got 4 meters on the DC to DC. Starter battery amps, 60. Auxiliary, 46 amps. And it's got the voltage drop, but not as bad as using that 10 meter, 13.3 millimeter squared cable. So we've still got voltage drop. It's ramped up the starter battery amps slightly to compensate, but it still can't put out 50 amps. Now for shits and giggles, what I might do is introduce a 6 or 8 millimeter lead, because old school people think that 6 mil cable can handle 50 amps. Yes, it can, but not over any distance, and I want to prove that today. Okay, so now I've introduced an 8 millimeter squared twin cable. It's a reasonable quality cable, this one. I actually use these for portable solar panels. I kind of like them. It's 5 meters long, and we'll see what it outputs. Okay, there you go, straight away, voltage drop again. Okay, 11.9 volts, still holding our 13.2 volts here. And we can only get 372 watt, or thereabouts 26.7 amps from the DC to DC. So guys, I'm going to keep harping on about this. Cable size is critical. You cannot get 50 amps out of this DC to DC charger unless you're on a short 1 meter run, unless you're going to be using somewhere between 25 and 35 mil squared cable at a reasonable, realistic length, which is going to be somewhere between that 5 and 10 meters. And I'd suggest 5 meters is 25 mil squared, and the 10 meter end is going to be that 35 mil squared. That's just my gut telling me that, but I reckon I'm pretty close. Some real world experience, guys. Tell me what you've done to overcome the voltage loss. And look at this temperature, 89 degrees. That's bloody getting hot. Yeah, like that's very hot to touch now. 89 is the internal of the unit. Let's check it. Oh, 68 degrees. Now I've mounted this to a timber board, and as I said, I spaced it out, but the board itself is not getting hot. But straight on the side there, 60 degrees, and on the very top where the heatsink is, 67 degrees. You know, that's heating up extreme. I would have used larger cables, but anyway. Yeah. I mean, the guys that have been watching this will probably see the time up here. Okay, you can watch the timestamp throughout the video, so you can see that I'm accurate and I'm not actually changing anything around. I'd never do that. I try and do the no bullshit reviews here on this channel. I like that it can output 50 amps. You're going to need big cable to do it. Otherwise, you're going to drop down to, you know, half the output of the unit. Okay, the temperature now has climbed to 98 degrees C, if you can believe that. Like, that's just a crazy number. And it's dropped, so it can't handle it. Okay, so it was showing a little bit higher just a minute ago, but now it's just dropped down and it's showing 21 amps coming out of charging, or 292 watts. And I'd say it's because the temperature on this unit is out of control. 75 degrees C on the surface, and they're saying internally with the probe it's 97 degrees. So what it'll do now is it'll probably come down in temperature because it's not outputting as much amps. And you can see starter battery is 21 amps, basically 21.5, and the auxiliary is 21.8. I'd say it's definitely the heat that's caused that. The voltage on this battery is still holding nice, and I have got a battery charger on it to boost it, so it shouldn't be a problem there. And you can see the cell voltages are really nice on that battery anyway. So what I might do is disconnect it now for a little while, let it sit, let it cool down, and then plug it back in and see where we get to. I guess the problem you're going to have is, I think I've been running this test for about an hour now, and you're potentially going to be driving for longer than an hour, and you would expect the unit would continue to output 50 amps if you could provide a big enough cable to it. So it's just climbed up a little now. It's just come back up to 25 amps. But yeah, look at that. So we know with the 8mm squared cable, we can't produce 50 amps over a 5 meter run. So at the moment, I've plugged it all back in with that 8mm square cable and the solar, and I'm getting a total of 30 amps in, or 400 watts. But you can see down here, the solar's now working. So I'm getting 2.8 amps of solar, 2.9, and there's the voltage. And you can see the little lines here. So it's working now when I'm not achieving the 50 amps from the DC to DC only. So yeah, it does work, but yeah, I'm not sure that I like it. I've let the unit cool down a little bit as well because it was getting really hot. And if we go back to the main page, you can see what's going on there. So it's showing the alternator and it's showing the solar. Well, it's a solid line on the solar, but so you don't really know by the looks of that there. But yeah, you're clearly getting it here. And when I drop the DC to DC out, it shows just the solar coming in. So I'm happy with all of that. It's a little bit awkward in terms of trying to work out what's going on. And look, that could be just me. Look, I'm a novice with this Renogy stuff. I haven't really played with it before. The temperature, like we were approaching 100 degrees according to this app. Yeah, that wasn't ideal. All right, so I'll introduce the short lead now with the solar and we'll see what happens. Okay, short lead plugged back in, solar's plugged in. We're achieving 2.39 amps at solar, which is 4.5 amps at the battery because it's a 33 volt panel. And there we go, the DC to DC is now just kicked back in, and we're getting 29-ish, call it, amps. And that's a combination of both. Now that should ramp up to 50 because it's the short lead, but it hasn't yet. Just give it a minute. I have noticed it takes a little bit of time to come back up. It's either that or the app is not working properly and needs to be reset again. That did happen. It froze up on me before. Not a major concern, but yeah, it's not something you'd want to happen all the time. So it's just come up to 29 amps. I'm just going to try and work out what's going on here because short lead definitely plugged in. Good voltage on the auxiliary battery, no problem with that. Sorry, I should say the start battery. Why won't you go back up? It's strange. I'm going to close it and then go back into it. Okay, it's showing 386 watts will go into the unit here, so I can just go a bit deeper. No, it hasn't come back up. I'll disconnect the solar and see whether that brings it up. So solar is this one. Okay, that's the solar's now disconnected. And we'll see whether that now jumps up. Okay, there we go. As soon as I disconnect the solar, it comes back up. And we're getting 46 amps out of the unit. And 52 out of the starter battery. Now that 46 or 47 amps could be a result of this still being hot. No, there we go, just jumped back up to 50. So it can produce the full 50 amps. It doesn't like the solar attached to it for some reason. I don't know what's going on there. I can't work it out. And quite frankly, I don't have days to sort it out. I mean, I've checked the settings. To me, everything looks like it should work. I'd say if you're going to use the DC to DC while you're driving, and then the solar when you pull up, it would work fine. And maybe that's the way it's intended to be used, but then when it derates, it allows the solar to come in. I'm not really sure, guys. Maybe you can tell me. Letting it run, I can't seem to get it over 97 degrees, which I'm saying that calmly, it just is crazy, but 97 degrees and it's derated, so the temperature seems to be holding at 97. When you look at that with, so 76 degrees on the top of the heatsink, and these cables here, we're getting to 58, 56, 58 degrees at these cables there. So I guarantee if I let it cool down a little bit, the current will come back up. Well, that's about it for the Renogy Rego DC to DC. I've done what I wanted to do with it. It does achieve 50 amps output. Just watch the heat, watch the cable derating, and watch the app. It seems to freeze up a little bit there. That could be just me. As a separate DC to DC charger, seems to work fine. The bonus being that it has the solar input, which looks like it doesn't really work when you're driving, unless it's derating and then the solar cuts back in. So yeah, for me that's a bit, I don't know, clunky, for want of a better word. It all seems to work. Am I going to give it a full thumbs up? No, I'm not. I'm going to leave it there on the side. You guys make up your own mind whether you'd want to buy one of these DC to DC chargers or not. Thanks guys, and stay tuned for the next one.